Evening everyone, just a quick video tonight. Just want to talk about one of my other hobbies, which is amateur electronics. Okay, so a lot of my projects require power. Everyday electronics run off alkaline batteries, such as the 9V, the AA and the AAA. A lot of these are not rechargeable. So I started venturing into lithium ion. Lithium ion batteries come in single cells like this, or in multiple cell, which are tagged together. They also come in a pre-manufactured form. This example is from an electronic cigarette. So inside there is two of these cells with extra safety wrapping around it, rubber bottom, rubber sides. Now every one of these cells is 3.7V to 4.2 depending on its charge state. This roughly works out an average of around 4V. Now if you buy these off eBay, they are not too expensive, but I prefer to salvage mine for free. Now these lithium batteries are fairly reasonable priced off eBay and several other sites, but I prefer to salvage mine for free. All these batteries you see here have come from either laptops or other mobile electronic devices. The way I get these from other devices is, an example here is a laptop battery. This stopped working or wouldn't power the... One example here is a laptop battery. This stopped working and failed to power the laptop anymore, and all this is a casing with multiple batteries like this inside. All it takes is one of these batteries to fail and the whole power bank becomes unusable. So what I tend to do is open these casings up, extract the batteries, throw the plastic away into recycling. Usually the batteries come with solder tags, and all these are is pieces of strip zinc, which is spot welded in 2 places per battery. So an example would be the 2 dots, the 2 dots, 2 dots, 2 dots, and that creates a power pack. So obviously there's various colours depending on the manufacturer and the capacity they can store. These, for example, 3000 milliamp hour, which means it will provide 3000 milliamps for an hour. That's also known as 3 amp hour, or 3 amps per hour. Some here are down at 2.2 amp hour. These ones are 1500. And these ones, I've tried to find the information on them, but it's unknown, so I will have to put them in a discharger to see how long it takes for them to fully discharge from charge. This unit is from an e-cigarette. This is rated at 18.5 watt hours at 3.7V, which, if we did the maths, would give our amp hour rating. Okay, so once you've opened the casing of the battery power pack off a laptop, say, and removed the batteries, what you want to do is take each cell, we'll use an example here, get a multimeter and test each battery. Okay, so once we've removed the batteries from the battery packs out of the laptop, I will disconnect each cell. I will then test it with a voltmeter and make sure there is a decent amount of charge in it and it's not completely flat or short-circuited. I'll then put it in a charger, such as this charger I've got here. This will electronically monitor and slowly charge it under set conditions. Once it's charged, I will put it in a discharger, make sure that it discharges safely and correctly. So what are these batteries used for then? The main reason is, for me, torches. I buy these torches online. These take one 18650 battery, and as you can see from the small pile I've got here, I've got an infinite amount. I can leave some on charge, take some with me to work, use some around the farm. So the little question of series and parallel. Let's say each one of these batteries is approximately 4 volts. This has 2 batteries, but because they're wired in parallel, the voltage stays the same, but the amount of capacity doubles. So this will still give 4 volts, but it's 3000 milliamps plus an additional 3000. Think of it as 2 water tanks, twice as much water. If these were to be mounted end to end, positive, negative, which is series, they would only give 2.2 amp hour, but they would give double the voltage. So this would give out approximately 8 volts. Now with batteries like this, you can't just fit them into a charger like this. They're designed for single cell only. So this is the new device I bought online. It's a LiPo balance charger. So all I need to do is, no matter how many cells I've got in parallel, connect the negative, connect the positive, and there could be 2, 4, 6, 8, 10, as many batteries as you want all connected this way. The only thing to make sure is that you don't overamp the charger. Now I know each one of these will happily take 1 amp per cell of charge. So what I'm going to do is tell it I want approximately 2 amps going in, 1 amp per battery, at 3.7 volts, which is what it classes this voltage at. Whether it's 4, 4.2, it's 3.7 on this machine. Press OK. So 2 amps going in at 3.7 volts. It's now going to confirm that the batteries are good. So 1 SER, and it's sensed 1 SER. It takes that as 1 battery or 3.7 volts. So I now tell it to start charging. So it's going to charge 2 amps. Currently the 2 batteries combined are measuring 4.8 volts. The charging time and the number of milliamps currently going in. Just to confirm, it's not the number going in, it's the amount of amps or milliamps consumed in total charge. So if both batteries were down at 1 amp out of 3 amps, by the time this is charged it would show 2000 plus 2000, or 2 amps per battery. Now obviously this is regulated by the voltage as well. If it sees the voltage get to the maximum threshold, it will turn off before it's filled the tanks. And that could be a sign of old age on the batteries, defective slightly, or just generally worn out. So that's the balance charger. That's for doing multiple batteries, and that can do multiples of 4, 8, 12, 16, 18 I believe, up to 20 volts maximum. So a laptop battery like this, if it actually was still okay inside, it was just say the connectors were faulty, if you could expose the positive and negative, you could connect to that and charge. In example, this one's wired for 14.8 volt and gives you 40 watt hours. You could even disconnect the battery what's failed, put a new one back in, and then charge it up, test it. If it's good, put it back in your laptop. So that was just a quick video tonight on the electronics side of the things I do. One more example of where you can find waste batteries is drills and other power equipment battery packs. This is all that's inside. A bunch of cells inside a plastic casing, all tagged up and going through a circuit board which both charges, protects and monitors the battery. This battery here, for some reason, does not give any power to my drill. It claims it's fully charged but nothing comes out, so I suspect something on the board has actually failed, and what I'm going to do is do volt checks across each battery, make sure the batteries are good. If so, the board's scrap, I will throw that away and I will probably salvage these batteries or use it as an 18 volt power pack.